Hey everyone. So today I thought it'd be fun to take a look at the new hard practice SATs that have gone up on Khan Academy's website. To give a little bit of background, I'm a professional SAT tutor. I've been working as one for about a decade now, and I've never really heard as much buzz around a test as I have around practice test 9 and 10. Now, the Khan Academy tests come directly from the College Board. So it's kind of a big deal that these new tests are challenging because it represents the difficulty of the SAT moving forward. So I thought it'd be fun, since I haven't seen practice test 9 yet, for me to go into the math non-calculator section and just go through it completely fresh and approach it how I would. So as I go through the test, I'll explain what I'm doing, but it is a 25-minute timer to answer 20 questions. So some of my explanations might be a little bit truncated. With that being said, I do offer one-on-one professional tutoring as well. There's a link in the description, but more about that at the end. For now, let's go ahead and jump straight into the test. All right, so here we are at the start of the math section. As soon as I click this button, it's going to start the timer. So let's go ahead and get into it. Here's just some directions, but the timer's already started, so I'm going to skip straight past these and get into the first question. Okay, so right off the bat, we have a system of equations question. A lot of students can find these pretty challenging, but what you really want to look for is just some way to add the top and the bottom equations together that lets you eliminate one of the variables. That's generally the easiest way to solve a problem like this. And here I see that if we multiply the top one by 2 and add it to the bottom one, we can get just x. Right, so 2 times 2x, and then 2 times negative y, and then 2 times 8. And that's going to be 4x minus 2y equals 16. Now we want to add that to the bottom one, and so that gives us 5x equals 20, so x equals 4. And now if we just look at our bottom equation here, x plus 2y equals 4, well then y has to equal 0. So x plus y, which is what it's asking for, must equal 4. Sometimes it gets a little sticky on these first problems. All right, there we go. Next question. So which is equivalent? Okay, so what we want to do here is just multiply out that 2 and that 3. We want to distribute it and then add them together. So what we get is 2x squared. Oops. We get 2x squared minus 2x plus 3x squared minus 3x. And what we end up with is 5x squared minus 5x. Okay, cool. So that's the first one. Say. All right, so which of these statements is true? All right, it's asking about the slope and the y-intercept, so we want to get it into slope-intercept form. So to do that, we just rearrange so that we have the y on one side and everything else on the other side. We end up with 2y equals 3x minus 4. Now, we don't have to solve this completely because it just wants to determine if the slope is positive and the y-intercept is positive or negative. And we can already see that the slope is going to be positive and the y-intercept is going to be negative, right? So the y-intercept is at negative 4, so negative and positive, yeah, right here. And let's see, front of a roller coaster is at the bottom of a hill, 15 feet above the ground, okay? So for questions like these, you generally just want to write down the numbers and their units, and then just look at the words for some information, because they give you a lot of additional info that you don't really need. The numbers are generally the most important part. So 15 feet above the ground is our starting height, so that's probably our y-intercept. And then 8 feet per second is our rate, so that's going to be our slope. So we can already see it's 8s plus 15 equals height. Yep, and so that's A. Okay, so, all right, electrician. So here it's just asking for us to determine the difference between two different values put in for h in this equation, right? And so all that we have to do is just go ahead and put in 2 for h and see that it gives us 150, right? Because 75 times 2 is 150. And that's going to be the difference. It's the same as if we put in 0 for h and then subtracted the two of them. I'm going to skip the work for that for now because I can already tell it's just a difference of 150, but I'll come back at the end and show you my method for that. Hey, this is Andrew from the future. This video already ended up being really long, so instead of spending more time going back and going over problems again, I decided to just make a separate video where I'll be going in depth through some more difficult SAT problem strategies. So you can expect that in the near future, and that'll show up now once that video is available. Okay, so this is the first one we've come across that's a little more tricky, I think. This is a arc length problem, and here we want to figure out the length of this outside arc, this ABC arc, and we know the length of this CDA arc, right? So the way that we're going to do that is create a system of equations. So x, this angle here, is 100, and so we know that 100 out of 360 times the circumference of the circle equals 5 pi. And then we know that the remainder of the circle, the remaining number of degrees in the circle, which is 260, over 360 times the circumference equals x. That's what we're trying to solve. Now we want to isolate the c in both of these equations. So isolate the c and then set them equal to each other. So the way that we do that, we end up with, we can cancel out a 0 in both of these. And I'm going to multiply over the 36, divide by 10. So we get 36 times 5 pi over 10 equals, this one's 36 times x over 26. And since we have the same values on both sides, we can cancel out the 36. And so we know that 5 pi over 10 equals 1 over 26 times x. And now we just want to multiply over the 26 and then divide it by 5. So 2 times 5 is 10, so it's 100. 6 is 30, so it's 130 divided by 10. We can cancel that, times pi equals x, which means x equals 13 pi. Okay, so that was a little bit trickier. That took some time, but let's go ahead and jump to the next question. All right, if 8 over x equals 160, then what is the value of x? All right, well, this one's actually pretty simple. There's a few ways to solve it, but I'm just going to do the first one that comes to mind, which is we just multiply over the x and then divide by 160. So then we get you get 8 divided by 160 equals x. Okay, well then we can tell that it's going to be less than a whole number, so it's got to be this 0.05 value. But it's also, you can do the math, it's not too bad. All right, in the equation above, a is constant. If no value of x satisfies the equation, then what is the value of a? Okay, so if no value of if no value of a satisfies an equation, then that means that the slopes are equal for both sides, right? So that means that we want the coefficient, this 2ax, to be equal to the coefficient for x on the other side. And I'll probably come back to this one as well and explain at the end a little bit more. So 2ax minus 15 is on one side, and equals, and we want to see 3 times x, that's going to be 3x, plus 5, plus 5x minus 5. I'm sorry, plus 15. 3x plus 15, I need to distribute that 3 out to the x and the 5. And then it's 5x minus 5. Okay, so we subtract the 5 from 15 to get 10. We just want to quickly make sure that, 15 over here, this negative 15 is not equal to this 10. And then we get 3x plus 5x, which is 8x. Okay, so we get 8x plus 10 equals 2ax minus 15. All right, to make this have no solution, we just need to have the same coefficient here as we have here, so that means that a has to equal 4, because 4 times 2 is 8. So, it's just having a little trouble registering, but it's okay. All right, a system of 3 equations is graphed. How many solutions does it have? I can tell right now it has one solution. A solution of a system of equations is where they are all equal, and this one spot right here is the only spot where that happens. So there's one solution. Okay, equation above is true for all x where a and b are constants. What is the value of a times b? Okay, so first things first, and I can see why people consider this test tricky because there's a lot of computation for a no calculator section. But what we need to do is just FOIL out this component here, right? We want to FOIL out the left side, or sorry, FOIL out the left side. So let's go ahead and do that. And we get a 5ax cubed minus abx squared plus 4ax plus 3 times, so that's plus 15x squared. And we can actually stop here because this coefficient and this coefficient are the two that matter, right? Because we want, this is the only place we're going to have a times b here. So if we take negative abx squared plus 15x squared, we have to say that that equals the coefficient of x squared on this side, which is negative 9x squared, right? So we want an a times b that ends up adding with 15 to equal negative 9, right? So it got to be 24. So that's C. Okay. Which of the following represents all the possible values of x that satisfy the equation above? Well, here we actually only have a couple of possibilities, so I'm actually just going to plug them in really fast instead of spending time solving them. So if you plug in 0, we get 0 over negative 3, which is just 0, equals 0 over 2, which is just 0. So then 0 is a solution. So it's A or B now. We've limited it down to. Now if I plug in 2, 2 over 2 minus 3 is negative 2. And then 2 times 2 over 2 is positive 2. So it can't be A. So that means it has to be B. So that was just a bit of SAT problem solving right there. Okay, so here we need to take this 5 on the outside and multiply it by the denominator of this fraction that we have over here, and then make a fraction out of it that way. So the way that we do this is we just multiply 5 times 2x plus 1, and we put it in the numerator, and then we add 1 to it. So 5 times 2x plus 1 is 10x plus 5. And then we just add 1 from the other fraction that we're already given, all over 2x plus 1. And so all that we're doing is 10x plus 5 plus 1, so that's 10x plus 6, right? Okay, so this is a vertex form question. So what you're going to need to do is just make sure that you know your vertex form equation, which is x minus, so it's some factor a times x minus h, which is your x value for your vertex, plus k, which is your y value for your vertex. So here we can tell, I can quickly tell that this is going to have a stretching factor a vertical stretching factor, A, of greater than 1. So I know that it's going to be this one. I don't have to actually do the calculation. But I'll come back at the end and do that. So we have a positive x value and a positive y value here, right? So this is the correct answer, A, here, because it's x minus h, so it'd be minus positive 3, which is our value of h. And I'll come back and explain this one a bit more. Okay, so in which of the following does the shaded region represent the solution set in the xy plane? Well, we can do a little bit of math to make this a bit easier. We're going to take y, we'll take the first one just as it is. Y is greater than or equal to x plus 2. All right, so that's going to be this line, right? This line right here, that's the one that's defined by y is greater than or equal to x plus 2. And then 2x plus 3y is less than or equal to 6. Well, let's subtract over that x. We'll get 3y is less than or equal to negative 2x plus 6. And just quickly, let's check. Okay, so all of these are the same graph. They just have different areas shaded. So we don't have to spend time solving the rest of that line to make sure that we can figure out which line is correct. We just can know that it's this negative sloped one because our first line has a positive slope. So 3y is less than or equal to this line, which means it's going to be below here. And it is greater than or equal to this line, which means it's going to be above here. So it needs to be in this region right here, and that's B. Okay, what is the set of all solutions to the equation x plus 2 equals negative x? Again, this is one where it's really easy to just plug in negative 1 and 2 really fast because you can see those are the possible answers. So we plug in negative 1, we get negative 1 plus 2 equals 1, and square root of 1 is 1. And that equals negative 1, right? So negative 1 is a legitimate answer. Negative 1 is equal to 1. Now we'll try 2. 2 plus 2 is 4, and the square root of that is 2. But then negative 2 is not equal to 2. So the answer is B. All right, and we're on to the short answer questions. What is the volume in cubic centimeters of a right rectangular prism? Okay, this isn't too bad. All that we have to do is just remember our rectangular prism equation, which is just multiplying your length times width times height. So 4 times 9 times 10. So we'll do 9 times 10 is 90 times 4 equals 360. And that's the answer. All right. Now, if x satisfies the equation above, what's the value of 2x plus 1? Well, this is just double 2x plus 1, right? And double 2x plus 1 equals 4. So dividing that by 2 would be 2. The answer is 2. Okay. Function g, the figure above shows this complete graph. The function g is defined by g of x equals f of x plus 6. So at any given y value here, g of x has the same value, just adding 6 to it. So it's 6 higher. What's the maximum value of the function g? Well, the maximum value of the function of f of x is 2, so it has to just be 2 plus 6, which is 8. And just a tip, as we're kind of coming to the end of this test, earlier on there were some really tricky questions in there, and if you found yourself stuck on any of them for even a minute, I would recommend that you skip ahead, because as you can see, there's some easy questions at the end in this short answer section, right? So when you skip ahead, you're kind of resetting the difficulty, and you make sure that you're answering as many questions as you can. Okay, triangle PQR has the right angle Q. If sine of R equals 4 over 5, then what is the value of tan of P? All right, so this is the obligatory trig question. A lot of students struggle with trigonometry, so I'm going to draw a picture here. If we have a triangle, we'll make it big. Okay, and we'll say that's our right angle right there. What is the value of tangent of P? Okay, sine is opposite over hypotenuse, right? SOHCAHTOA, so sine opposite over hypotenuse. And we have a right angle Q. Sorry, that's a terrible Q. We'll fix that. Okay, and then we have tangent, we want tangent of P, and then we'll have R up here. And we know that sine of R is 4/5. Okay, so opposite is 4, and the hypotenuse is 5. Well, here we can tell the easiest way to solve this problem is to just realize that this is now a 3, 4, 5 right triangle. And so we can figure out our final side over here. And we want to figure out tangent of this angle, tangent of P. So tangent is TOA, opposite over adjacent, which is 3 over 4 here. So the answer is 3/4. Okay, that was a trickier one. There's other ways to solve that if you have more time, and I'll try to come back to that too. Okay, graph of the linear function f is shown in the xy plane above. The graph of the linear function g not shown is perpendicular to the graph of f and passes through the point 1, 3. What is the value of g of 0? Okay, so we're going to erase this. And when you have a perpendicular graph, it means that you take the inverse, the negative inverse of the slope of your initial graph. So here, this slope is going to be, so when it's rise over run, right? So when it goes down 2, so -2, it goes over 1, so over 1. Slope is -2. And then we can find the rest of the equation by looking here. This is a y-intercept of +3, so y equals -2x plus 3. That's our equation for our initial line. Now we want to find a perpendicular one, so we have to take the negative inverse of the slope and set that as our new slope. So then y equals +1/2 x plus b, some unknown value. Okay, graph of the linear function is perpendicular and passes through the point 1, 3. All right, well now we just plug in that point. So x is 1 and y is 3, so 3 equals 1/2 plus b. And what we can do is subtract over the 1/2, so you get 5/2 equals b. And it's asking for g of 0. Well, that's the same as your y-intercept, right? So it's 5/2. All right, so done. That was a reasonably challenging test. In a way, with how much buzz was surrounding it, I kind of expected it to be even harder than that. There have been practice SATs before that are of a similar level of difficulty. Practice test 3 comes to mind. The main thing that I noticed that was unique about this test was that it pulled from a large pool of what I would consider the more challenging types of SAT questions that get asked. In every test, you're going to get 2 or 3 questions per math section that come from more challenging areas of math, like systems of equations, chords, and trigonometry. And in this test, we really had every type of hard question all put together. So there are a lot of areas that if a student didn't know one thing and made the classic SAT mistake of just spending too long on one problem, they would probably get stuck and lose a lot of points because this timer is so tight that you wouldn't make it through the entire test. So one key thing to keep in mind is if you come across something that you don't understand, that's okay, but you should definitely skip it and move forward in the test. And if you keep finding problems like that, then move all the way to that short answer section at the end, which really resets the difficulty. So you might find a couple more that are a bit easier, a bit more quick to tackle in those last 5 questions that are in a different format. A lot of students are kind of scared of the short answer questions, and so they put them off until the end because they think that multiple choice is easier. But the reality is some of those short answer questions are basically equivalent to what does 2 + 2 equal. All right, so that's about it for this video. Thank you all very much for watching. I'll be posting more videos soon where I go through more specific tips about how to tackle certain SAT problems that are more challenging or that maybe appear more challenging but are actually fairly easy. If there's any videos in particular that you'd like to see in the future, or if there are any questions that you have, please just ask them down in the comments below. I read every single one of them. So with that being said, thanks very much. Keep improving those scores. If you're interested in taking your SAT studying to the next level, head on over to my website, cresttutoring.com, where I offer one-on-one SAT tutoring sessions via video call. If you click the Getting Started tab and send me a message mentioning that you saw this video, I'll give you 20% off of our first lesson together. That's cresttutoring.com, link down in the description.